Welcome to Gumber's Mathematics classes. Hope you liked the video. Subscribe our channel and press the bell icon to never miss another updates.
Let's see what is the relation between zeros of a polynomial and the coefficient of the polynomials. Zeros and the coefficients. This we have done earlier also. Very first we'll be finding the zero of this polynomial. Ax is equal to minus b and x is equal to minus b by a, or we can say that this is equal to negative of constant term divided by coefficient of x. Coefficient of x. This is the relation between 0, this is the 0, and the constant and coefficient. Let's see, is there any relation between zeros and constants and coefficients of quadratic polynomial also? For this, let us consider alpha and beta are its two zeros. If alpha and beta are its two zeros, then it can be written as these are the zeros, it means x minus alpha is one of its vector and alpha x minus beta is second, it's one of another vector. So we can write this quadratic polynomial as k times of x minus alpha into x minus beta. Now just multiply these, will be getting x square minus alpha x minus beta x plus alpha into beta, and this is equal to k times of x square minus k times of alpha plus beta into x, we have taken common, and this is alpha into beta. If you compare it with the standard form of polynomial, then we can observe that a is equal to k and b is equal to minus k into alpha plus beta, and c is equal to alpha into beta. Or if we find the relation between alpha and beta, let us consider separate out alpha and beta. It means alpha plus beta is somewhere hidden here. Where it is? This is minus b times of k. Minus b divided by k. Why to take k as k? We can take it as a, because k is equal to a only. And what about this? K also, here should be k. And what about alpha and beta? Alpha and beta product is equal to c by k, where k is nothing else, that is a only. So here we can see that the relation is in front of us, that alpha plus beta means sum of the roots is hidden somewhere in minus b by a. Negative of sum of zeros is equal to, where is the sum of zeros? Negative of constant, coefficient of, it should be coefficient of, I must write it correctly, so I am writing it, this is not constant, this is of coefficient of b is the coefficient of x, and divide by coefficient of x square. And if we are talking about the product of the roots is equal to c by a. C is what? C is this constant term, constant, divide by a. A means the coefficient of x square. Coefficient of x square. This is a very good and interesting also to see that somewhere the sum is hidden at this minus b by a and product is hidden in c by a. Let's consider one example to verify this also. Is it so or not? Let's try to find the roots of this equation. Very first, two common. So x square, this is not an equation, it's a expression, minus 4x plus 3. So let's find the roots with the help of its splitting middle term, plus 3 and 2x, x minus 3 minus 1, x minus 3, and this is x minus 3, x minus 1. And the zeros are either x is equal to 3 or x is equal to 1. or we can say alpha is equal to 3, one of the 0, and beta is equal to 1. So let's check here that alpha plus beta, sum of zeros, which we were saying as minus b by a. Is it so? Alpha plus beta is equal to 3 plus 1, that is equal to 4. And 4. Is it equal to? Is it equal to minus of 8 by 2? Yeah, yes, this is. So we can write that is equal to minus b by a. Now let's find alpha into beta. Alpha into beta means 3 into 1, that is equal to 3 only. And is it equal to c by a? Yes, this is equal to c by a. So hence it is verified also. Great. Both ways we have found, and it's true that product of the roots is minus b by a, and sum of the roots is minus b by a, and the product of zeros or roots is equal to c by a if the standard equation is of the form ax square plus bx plus c, where a is not equal to c. Now we are going to consider is there any relation between zeros and coefficient of a cubic polynomial also? Yes, there is. Yes. Let us consider alpha, beta and gamma are the q zeros of the given polynomial. As we have earlier also discussed, according to the fundamental theorem of algebra, that it can have at most 3 zeros only if it is a cubic polynomial. So where is alpha? What is the relation? Where is the sum alpha, beta and gamma? Their sum is equal to minus b by a, and alpha beta plus beta gamma plus gamma alpha means the sum of the zeros taken 2 at a time is equal to c by a. This you can just learn this because it is not the proof of, in your syllabus. So a product of the roots is equal to minus d by a. Now we are going to see, is there any relation between the zeros and the coefficient of a biquadratic polynomial also? Yes, there is. Biquadratic polynomial of the form ax4 bx cube cx square dx plus e. What's the relation between these? Let us consider there are 4 of the zeros, that is alpha, beta, gamma and delta. The alpha plus beta plus gamma plus delta. Any guesses where is it? Yes, absolutely right. If you are guessing, you can pause the video, and you can see that this is equal to minus b by a. Now the roots, if you are taking sum of the roots, if you are taking 2 at a time, alpha beta, beta gamma, gamma delta plus delta alpha. More combinations are also left, alpha and gamma plus beta and delta, and this is equal to c by a. And now 3 roots at a time, alpha beta gamma plus beta gamma delta plus gamma delta alpha plus delta alpha beta. This is equal to, absolutely correct, absolutely, that is equal to minus d by a. And now 4 at a time means alpha, beta, gamma and delta. This is none other than e by a. Absolutely correct. This is the relation between the zeros and the coefficient of different kind of polynomials. Let's have an example. Find the quadratic polynomial. If the sum is given to you as well as product, and we are having sum is equal to minus 3 and product is given to us as 2. How to frame a quadratic polynomial of this? As we have seen that ax square plus bx plus c is equal to k times of x square plus alpha plus beta into x plus alpha into beta. While finding the relation between this, we have done also, here we have done this, we found this relation. So with the help of this, we can find the quadratic polynomial if alpha beta are given to us. Let's try to find. So we just need to put the value in this, that k x square plus sum is given to us as minus 3. So here was negative also. So minus, it was minus 3x plus product of the roots is equal to 2. So here are infinite many quadratic polynomials which are having sum as -3 and product as 2. So here is one we have written. You can consider any value of k. If k is equal to 1, one of the answer is x square plus 3x plus 2. If you will take a k is equal to 2, you will get another value, that 2x square plus 6x plus 4. If you will take k is equal to 3, you will get a polynomial as 3x cube square plus 9x plus 6. Thank you.